finding something. Soup, he's coming around.
Con, sonar, the Akula's turning towards sir. Con, sonar, torpedo on the water bearing 241. Con, sonar, second torpedo on the water bearing 242.
All ahead flank, right full rudder.
Con, sonar, 3,000 yards and closing, sir.
Maneuvering con, cavitate, cavitate. Sound the collision alarm. Sound collision alarm, action.
2,500 yards.
Rig ship for impact.
Hang on, gentlemen. 2,000 yards. 1,500 yards. Bearing 070. 071. 1,200 yards. 1,000 yards and closing fast.
Con, radio, receiving emergency action message. Recommend alert 1. Recommend alert 1.
950 yards.
Launch a 5-inch evasion device. Launch your countermeasures.
Countermeasures away, sir.
Shift your rudder to left full.
500 yards and closing fast. Fast. 300 yards and closing, sir. Sir, the first torpedo's going after the countermeasures. They missed. Sonar, con, sonar. Second torpedo incoming. It's gonna be close. It's gonna be close.
Radar is actually an acronym that stands for Radio Detection and Ranging, and it works by sending out radio waves that bounce off the object and then come back to a receiver. Based on the time delay between sending and receiving transmissions, it's possible to calculate where an object is. And based on how much of the signal gets returned, an object's size can be determined.
Okay, so in the problem, we already have two given points. We have A, which is 6 and 50, and B, that is 3 and 300. We also have a formula we can use to find the distance between the two airplanes, and that is D equals R1 squared plus R2 squared minus 2R, and R squared cosine theta 2 minus theta 1. So let's look at what else we have that is given. R1 is 6, R2 is 3. We also have theta 2 as 300 and theta 1 as 50. So according to the formula, plot in the appropriate points. So now it becomes, if you use your calculator, 45 minus 36 cos 250. So that equals 7.58 miles. Now we have to graph. So the first thing we want to do is find A. A is 6 and 50. So on the x-axis, locate 6, and then find the degree 50. Once you've done that, draw a line. Then locate B. B is 3 and 300. So on the x-axis, locate 3, and try find the degree 300. Once you've done that, draw a straight line connecting the two dots. And that is how you sketch the situation.
R2D2, Your Highness.
So the first question is asking, what are the rectangular coordinates that the robot will need to calculate? So we know that r equals 8 and theta equals 300. So by using the conversion formula, plot in the appropriate points. So it becomes 8 cosine 300. Use your calculator to find the answer. So the answer is 4. So the next conversion formula we're going to use is y equals r sine theta. So then you're going to plot in the points, which is r and theta. So it becomes y equals 8 sine 300. Then again, use your calculator to find the answer. It becomes negative 6.92. So now we have the answer for the first question, and that is the object is located at the rectangular coordinates 4 and negative 6.92. We're going to answer question 2, and we need to find the distance and angle measure of the missile relative to the front of the robot. So we can use the conversion formula r equals x squared plus y squared. X equals 4 and y equals 8. So you plot that in your calculator and you find the answer, which is 8.94. Now we're going to use the other conversion formula, that is theta equals inverse of tan y over x. So our y is 8 and our x is 4. So it becomes inverse of tan 8 over 4. Inverse of tan 8 over 4. Use your calculator to find the answer, and that is 63.43 degrees. So therefore, the missile is located at the polar coordinates of 8.94 and 63.43 degrees.